Hi, welcome to Integration by Parts. Okay, this is my makeshift classroom. I'm actually in my garage. Okay, so this is Lord Vader to keep me company, to keep me motivated as well. And yeah, this is my whiteboard. Okay, so I'm going to try and see if I can do some good stuff from this. Okay, you've done substitution. Now this is integration by parts. Okay, and it starts on page 307. Okay, so it's just to be on page 307. I'm going to introduce the by parts formula because it's a formula that you need to remember and use to be able to integrate some interesting stuff. Okay, so it's a little bit like the product wall or quotient wall of differentiation, but it's called the by parts formula for integration. Okay, and this is it. So you've got the integral of u dv dx is equal to uv subtract integral v du dx. What does that actually mean? Tell you what, I'm going to use an example to show you, okay? And I'll use example 16 in the text to help you out. So you've got the integral of x cos x dx, okay? So integral of x cos x dx. Okay. What we need to do is, a little bit like the product wall or quotient wall, we need to decide to make one of those be u and the other one be not v, but dv dx. Okay, so I'm going to write that over here. This is where I'd really like to have more board space, if I'm honest. Okay, so I'm going to let u equal x, and the other one I said is dv dx. Is cos x, like that. Okay, so for the moment, just go with it. Okay, and I'll explain to you afterwards why sometimes it matters that you make the right substitution. Okay? So I'm just going for u as the first term and dv dx as the second term for the time being. All right. Now, a little bit like the product wall, we've got to find what du dx is. Okay. So I'll just write that down here. If I can squeeze it on, du dx is equal to 1, of course. Now I'd normally like to write what the other term is here, but I've run out of space, haven't I? So I'm going to put it here. Now, since we know what dv dx is, we have to work out what v is. Okay. So you can see how we do that. If dv dx is cos x, then we've got to integrate that to work out what v is. Okay, so integral of cosine x, that is sine x, and if you're not too sure, just differentiate it. There we go, v is sine x, differentiate it, and you get cos x. Okay, and then all we do is we just substitute it into the formula. Okay, so we should have this. I'm just going to use capital I for the moment, mainly because of the lack of board space. Okay, so this, which is our original integral, okay, is going to be u times v, so u is x and v is sine x, so x sine x, and then subtract the integral of, it's v du dx, okay, so that's sine x times by 1, so it's just sine x dx, okay. Now incidentally, why did I write those in blue? It's just to remind you that you're integrating with respect to x. You're integrating this with respect to x, see there it is, and you're integrating this with respect to x, there it is as well, okay? If you're not trying to remember the by parts formula without the dx's there, you can do, okay? Well, this is how I normally remember it, like this, you see. The integral of u dv dx is uv subtract integral of v du dx, okay? So that's u dv dx, and then put it into the by parts formula. You've got uv subtract integral v du dx, which is 1, and then of course integrating that with respect to x. Okay, but just to make it right, I'm going to slip in the dx's back there. Okay, there we go. Now what this does for us is it makes it a much simpler integral. Okay, so we start with x cos x. Okay, this is part of our final answer, so don't touch that. We'll leave it alone. But now what we've got to do is integrate this, and you can see that that is much simpler than that. Very simple now. So in our next line, you've got x sine x, subtract, and then we've got to integrate what sine x is. Okay, and that's going to be positive cos x down here, isn't it? Because integral of sine x is negative cos x, so subtract negative cos x, you get plus cos x. Okay, and we mustn't forget the plus c. There we go. Okay, so our final answer is this is x sine x plus cos x plus c. And that is it. Okay, I'm just going to pause the video just to check to see if it's come out all right, and then I'll continue.